Let me quickly share two interesting facts about how an understanding of exponential functions can save humanity. One, in containing the spread of infectious diseases, and two, in containing the outbreak of a radioactive decay. How do we differentiate this exponential function? Well, I'm going to share one approach with you. One, we can take the natural log both sides. Therefore, the exponent t here can be written as a product of the log. Therefore, I have t times the natural log of 3, and on the left hand side I have the natural log of y. So now we can find the gradient of the function. Therefore, dy dt, which is the gradient, it's just 1 over y. We differentiate this, we get natural log of 3. Therefore, dy by dt, we multiply both sides by y here. So dy dt equals to y times the natural log of 3. But y equals 3 to the t. Therefore, the gradient, or dy dt, equals to 3 to the t instead of y, natural log of 3. Here we have figure 2, which shows a part of a sketch of a curve C with parametric equations here as shown as x equals 1 minus a half t and y equals 2 to the t minus 1. And the curve crosses the y-axis at the point A and crosses the x-axis at the point B. And you're required to show that A has coordinate 0, 3. So at the point A here, the x value would equal to 0. So let's write at A, x equals 0. You are given the parametric equation x, so we have x as 1 minus a half t. So let's equate this to 0 and find the value of t. Let us add a half t both sides. That equals 1. T equals 2. So when t equals 2, we can find the y value. The equation for y is y equals 2 to the t minus 1. When t equals 2, then we have y equals 2 squared. That's 4 minus 1. So we get y as 3. So here x is 0 and y is 3 as required. Let's move on to part B. Find the x-coordinate of B, of the point B. So at B, y equals 0. Let's write the statement. At B, y equals 0. We have y as 2 to the t minus 1. So y equals 2 to the t minus 1. So when y is 0, we have 2 to the t minus 1. Let us add 1 both sides. Therefore, we have 2 to the t equals 1. So 2 to the 0 is 1. Therefore, 2 to the t would equal to 2 to the 0. Hence, t equals 0. So when t equals 0, we can find the x value. So we have the equation for x as 1 minus a half t. So when t is 0, we have x equals 1. So it means that we can write the coordinate for b. We can write the coordinate of b as, which is just 1, and then the y value is 0. Okay, let's look at part C. We're asked to find the equation of the normal to C at the point A. So at A, here we would have a tangent, and also the normal is perpendicular to the tangent. So if m is the gradient of the tangent, it means that the gradient of the normal would be minus 1 over m. So how do we find the equation of the normal? Well, first we need to find dy by dx. So let's write c here. So dy by dx, which is the gradient of the tangent, we have y with respect to t, so we have then dy by dx equal dy by dt times dt by dx. We have y, let's write y equals 2 to the t minus 1. So how do we differentiate this exponential function? Well, let's add 1 both sides. So we have y plus 1 equals 2 to the t. Let us take the natural logs both sides. Therefore, the t here can be written as the product of the log. Hence, we have now we can find dy by dt. So dy by dt would be 1 over y plus 1 equals to the natural log of 2. So dy by dt, we multiply both sides by y plus 1, so we would have y plus 1 times the natural log of 2. So we have y, so let's write here then. We're going to replace this y with 2 to the t minus 1. So we can write but y equals 2 to the t minus 1. So where we have this y, wherever we have this y, we're going to replace it with 2 to the t minus 1. So this y here that I'm shading in yellow needs to be replaced with 2 to the t minus 1. So therefore, dy by dt equal to 2 to the t minus 1 plus 1 there times the natural log of 2, which is 2 to the t times the natural log of 2. Okay, so that's what we have for dy by dt. Let us find now dx dt. So we have x as 1 minus a half t. Therefore, dx dt equals minus a half. But if you notice here, we have dt dx. We need to find dt dx. So we need to find the reciprocal of this. So let us write dt dx then. dt dx then is the reciprocal of minus a half, which is minus 2. So it means that here we have dy dt as 2 to the t natural log of 2 times dt dx, which is minus 2. So we can write then the gradient of the tangent is 2 to the t natural log of 2 times minus 2. Therefore, the gradient of the normal then is going to be 1 over 2 to the t times 2 natural log of 2. So we can write the equation then of the normal, which is y minus y1 equal to m into x minus x1. So at the point at A we have 0, 3. So at A we know that t equals 2. We can write down this value as well, t equals 2. Okay, So let's write the equation then. So we have y minus y1, which is 3, into m. M here, gradient of the normal is 1 over 2 times 2 to the t. Here t is 2, 2 to the 2, over the natural log of 2, into x minus x1. x1 is 0. So we have written the equation there. So we have y equals to, that would be 2 times 2, that's 4 times 2, 8. So we have 1 over 8 natural log of 2 x plus 3. And that's the equation of the normal. Thanks for watching. Please remember to like, subscribe, share, and also give a comment. And please look out on the channel for other videos that can help you.